Hello friends, today we will discuss one of the topic that is basically energy stored in a capacitor. So to understand this, first suppose I took example of a spherical capacitor. This is the wooden handle and over it is spherical capacitance is there. This is the wooden handle. And suppose the charge on this capacitance, the charge on this capacitance or spherical capacitance is Q and its voltage is V. You all are familiar that what is the voltage V? Voltage, or I can say potential of a surface or potential of a point is basically equivalent to, if we bring a unit positive charge from infinite to a certain point, then the amount of work done which we have to do, that is basically potential of that point. So suppose if I want to find out the potential of point A, then I have to bring unit positive charge from infinite to this point, and whatever amount of work done I have to do or the system has to do, that is equals to potential of the point A. I can say potential of any surface A. Suppose that is V. Now in this case, if I saying that this is my basically spherical capacitor and its potential is V, so you understood that its potential is V, then it means if we want to bring unit positive charge from infinite to this surface, then amount of work done that is equals to V. Now we have to find out how much energy. Suppose now I want to store further charge on this, Q further charge on this, and what is the amount of work done I have to do? So there is a answer in your mind, sir, because to bring the unit positive charge, we have to do the amount of work done that is equals to V. So if I will bring Q more charge, then the amount of work done will be Q into V, and that is the energy. But that is not correct. That is wrong, because while we are giving it a charge, we are giving it a charge in small quantities. We are not giving it exactly in. So what happens? While we are transferring the charge to this capacitor, okay, I am taking on next page. So again, this is our parallel plate capacitor. Spherical capacitor, and charge on it is Q, its voltage is V. So first I will bring a charge dQ from infinite, dQ. Then what happens? As this charge or as this amount of work done will be done, suppose while I am moving the charge, then what happens? Its potential will also increase, because amount of work done is increasing, so its potential increases. So as we bring the charge, its potential also changes. It means potential is here variable. So directly we cannot multiply Q by V and we can calculate. So now first if I will bring the dQ charge, then what will be the amount of work done? If I bring the dQ charge, then what will be the amount of work done? V into dQ. Now what is V here? V from the formula, if this capacitance of this spherical capacitor is C, then I can write it is Q by C into dQ. So I want to transfer, or I want to shift a charge Q. So what I will do now, I will shift a charge Q, because this is variable now. So what I will do now, I will integrate it from 0 to Q, and then I will put it Q by C into dQ. So when I will solve this, what it will become? This will become Q square by 2. So finally the formula will become 1 by 2 Q square by C. So I think you understood that this is the basically, first we have to understand the concept of potential, then we can calculate why the formula is half Q square by C. So when we solve this, Q, what is Q? Q is CV basically. So if I put the value of, so it will become half C square V square upon C. So the second term, the second formula will be half CV square is also. Thank you.